noticed that you did a high cognitive demand task and you gave that to your students. Can you tell me the difference between a high cognitive task and a low cognitive task?
Yes, I sure can. So I'm going to start with a low cognitive demand task, and that's going to be your, just do they know their facts? It's going to be your algorithms. The low cognitive demand tasks are going to be formulas. It's going to be focusing on maybe what would be the prior memorization. It's definitely solving an equation. Most likely a lot of the kids will be able to do it in their head. You're not going to be able to really dig into their thinking and what their ability is because you're just getting an answer. Where a high cognitive demand task is going to require them to analyze the information. They're going to be making connections, drawing conclusions. There is no algorithm, and there's really going to be more than one way to solve a problem, and possibly even more than one answer. It's definitely, there's no algorithm necessarily involved. It's not predictable. And I've got, if you'd like, I've got a sample of a question that I had posed to my students that definitely was the highly cognitive demand task. And so this question here, it starts with, there are 16 students in our class. The class sits at 3 tables in the cafeteria. Each table has 6 seats. How can the 16 students sit at all the tables? This sample here, I was very proud as I watched the 2 partners work, because they both read the question, and I've trained them from the beginning of the year to explain the question to make sure that they both understand it. And then they choose the manipulatives if they want to use manipulatives, and then they come up with a plan. And I watched them, definitely you're familiar with that productive struggle where they are being challenged, they're engaged, they're inquisitive, but I'm not giving them too much information. I'm letting them work through the problem, and that definitely existed here. They impressed me where through productive struggle, and it was a definite productive struggle, they came up with one table having 6, another table having 6, and the last table having 4, for a total of 16. Well, then they had to come up with another way, and they, again, through a lot of thinking and a lot of moving the manipulatives around, realized you don't have to have 6 at each table, and they came up with 5 plus 5 plus 6 equals 16. Where the highly cognitive demand task is so successful for a teacher in knowing the student's thinking is they're able to also explain it. I know it's right because 5 plus 5 is 10, and adding 6 more is 16. I know 6 plus 6 is 12, and adding 4 more makes 16. I was also proud of them because they're using their make a 10 strategy, and they were also using their doubles. So I looked at this as being everything that's taking place in the classroom. I can look on this paper and I can see them using every strategy. You're not going to get that in a low cognitive demand task. This student here also, same thing, worked with their partner. Each read the question, each explained what they thought the question meant, decided their manipulatives, and came up with a plan. Exact same problem. There were 16 students in 3 tables. You couldn't seat more than 6. Through that productive struggle that is so beneficial to the kids, where they're optimizing their learning, they were able to come up with the same answer of 4 plus 6 plus 6 is 16. They used doubles, and then 6 plus 6 is 12, and then they added in their 4. So all was going well until they had, is there another way? And with is there another way, they were able to manipulate the numbers and still come up with 16 using 3 digits, and they did 6 plus 7 plus 3. However, they never went back to the question, and had they gone back to the question, they would have realized no more than 6 people can sit at a table. So I know I want to have them always go back, make sure that answer makes sense to the question, and that will be my next step with them. Still, though, you can see the level of thinking taking place. With this group here, again, exact same question, 16 students at 3 tables, 6 at a table. I could tell at the very beginning that the students did not understand the question being asked. And through the productive struggle, they were giving it their all, but they definitely broke down at the point of reading the problem. And I did eventually pull this group, and I did give them some good focusing questions to try to guide them to where I wasn't necessarily funneling the questioning, but focusing. And ultimately, this particular group really pulled, knowing that there were 3 tables, they pulled 3 tables. Here's the table, 6 plus 6 plus 6. They didn't quite even understand where their answer was coming from or what the meaning was. And that's where, as a teacher, you need to come in and kind of redirect them and give them those focusing questions to help them work through the problem. But that was done later.
Gotcha. And then I noticed here, you had said this in one of the previous students' papers, where they're doing pictorials versus they're counting by ones instead of making 10, or like you're saying, making double. So that was some of that as well.
Yeah, and with this student is not ready to do anything beyond adding by 1. However, I look at some of my other students, and I almost did feel like, as a teacher, they needed to be told, you don't have to continue to count by ones. There is an easier way, and maybe a better way for where they're at with their math. And they really had to be taught that. Had they not been told it was okay, I would say the majority of my class would still be doing that. But once they were given almost permission and told, let's come up with an easier way, they're on board with it, and they're doing that.